Hey guys, welcome to this particular session today. And in this video, I'm going to be talking about data analysis fundamentals, right? So this is the right video for everyone who wants to learn data analysis, regardless of your discipline, your background, where you're actually coming from. This is actually the right video for you to get started with data analysis. We're going to be talking about data analysis fundamentals, kind of a complete beginner's guide, some key concepts and terminologies explained. So, what this video is designed to provide is that it just kind of gives you an insight of some of the terminologies you need to have before getting into data analysis. All right. So, if you're transitioning into data science, machine learning, you want to become just a pure data analyst, or maybe you want to also is a kind of get into some other roles. Of course, this is the right video for you. And we're going to be getting started. My name is David Chenchaminese, founder of Sensei Team and founder of Synalytics, which is a data-driven company, and also dealing with robotics. Now we're going to be talking about today I'm going to be walking you through the building blocks of data analysis, all right? So from understanding what data is all the way to finding out real insights, that you don't really need any mathematics degree for you to be in this particular class. You don't need any prior experience, just curiosity and willingness to learn. That's all you need for you to get started. And the first thing I'm going to do right now is what is data, right? Now that's what we're going to be talking about. So just kind of think about it as the raw material of analysis. That is what data is, okay? We're going to talk about type and sources of data. Where does this data come from, okay? And how is this classified? We're going to talk about cleaning and preparing all of this data, kind of making data ready for analysis. Of course, that's what we're going to be looking at. And then kind of analyzing and visualizing. How do we do it, okay? How do we find some kind of meaning and, present insights from this data? And then we're going to be talking about real world applications of data, okay? Putting it all together with a healthcare example. Now, the first question here now is what is data? All right. So everybody here, you are attending this class, you've been hearing about data analysis. Now we're going to split it into two. We have data and we have analysis. Now think about data as raw facts. All right. Numbers. It could be numbers, it could be words, it could be dates, it could be observations that haven't been processed yet. So on their own, they don't tell a story. So, but once you organize and interpret them, they become an information, something meaningful and useful. So when we talk about data, data is something that is raw. So it can be anything. Let's say, for example, the number of friends you have, the number of children, the color of your clothes. It could be just literally anything. That is what data is. All right. So and many a times they're kind of an unprocessed facts collected from the world around us. So, for example, we could talk about somebody's age. Oh, this person is 24, this person is 34, this person is 56, this person is 22, and all of that. That is just data or data. Name also, could say name, your name is John, your name is Aisha, your name is Peter, your name is Paul, whatever bullshit it could be, that is what we call what? Data. It could also be temperature, okay? The temperature is 98.6 degrees Celsius, Fahrenheit, whatever, whatever. All these things are just data. They are unprocessed facts. We can't really unravel any insights from it. Okay? Now, we can also look at it from information. Now we talk about data here. Now, how about information? Now, information is something that has now been processed. When we say, how old are you? I am 30 years old. I am 21 years old. I am 24 years old. I am 25. I'm 27. I'm 26. Or what is your name? I am David. I am Chinechorem. I am Promise. I am Fanta. I'm Cook. Right? So all these things now becomes processed because we've now processed it at some point. Or I can actually say that most patients that come to this hospital are between the age of 50 to 30, or between the age of 90 to 100, or the average body temperature is normal, or cells are highest in Q4. You see that all these words, all these particular sentences that I'm using now, they seem to be what? Processed. And that's what we call what? An information. So key insights for you to know now is that data is just the ingredient. Then information is now the cooked food that we have, okay? While analysis now is the cooking process that transforms one into the what? Now, so what's data analysis now? Because we've talked about data as the maybe raw material, and then we talked about information as the meal. I would say that analysis is how you cook that particular food. So now let's have a kind of a much more better explanation of data analysis. Now, data analysis is the process of examining, cleaning, and interpreting data to discover useful information, right? We can discover useful information, draw conclusions, and support decision making. So it's just like being a detective. Just think about it as being a detective. You look at the clues, you try to figure out, what really happened and I maybe what you're definitely going to do next. But essentially, what we are saying here now is that it involves the process of going to the field to examine, collect. After collecting it, you clean it. After cleaning it, you do what? You interpret that data to now get information. That is what we call what? Data analysis. So data analysis is the intermediary between data and information, just like we explained. So the first thing we do is to do what? We collect data, we clean the data up, we analyze it, then we try to interpret what? Results. Those are actually what we do whenever we talk about what? Data analysis. And basically what you need to understand is that what? Every data analysis protect every data analysis project, whether it's in healthcare, whether it's in business, whether it's in everyday life, they follow this first step. The first thing we always do, because we're going to be hearing about data analysis all the time. Your friends are definitely going to be talking about it. Data analysis did this, data analysis did that. But it's always going to follow these four steps, which is what? Collecting the data, cleaning it, analyzing it, and interpreting what the result. So you need to actually master this step. Just have it in mind. That is what you're going to be doing. Now, at some part of this particular series, we might decide to start using tools like SPSS, Power BI, Python, and all of that. But the most important thing you want to understand is that what data analysis is going to go through these four procedures. Now, we've talked about here, remember we talked about what data analysis is and the procedures. Now, we're going to be talking about types of data because remember, we have the word data and analysis. So we're going to be looking at what are the types of data. Now, not all data is the same. Before you can analyze anything, you need to know what kind of data you are working with. There are two main types of data, and understanding them is definitely going to change how you analyze and categorize your data. Now, I'm going to explain this in a very, very, very simple manner because there are basically two types of data. Now, we have the type of data that we refer to as the what? Quantitative data. And we have the one that we refer to as the qualitative or categorical data. Now, for quantitative data, it's more of a numeric data, anything you can measure or count. So it could be something like maybe weight, body mass index, height, monthly salary, blood pressure, your age as of last birthday, your probably sickle cell count, whatever type of parameter that uses calculations is what we call what? Quantitative data. And again, it uses calculations like average, total, percentage. So anytime you're having any kind of figure like that, we classify them as what? Quantitative what? Data. This is very fundamental for you getting started in what? Data analysis. Now, another one, guys, we have is what we call the categorical data. And the categorical data here, we look at what? Label-based data. They are what? Group or categories, not numbers. So we can also call them qualitative data. For example, we have gender, it could be male or female. We have blood type, it could be maybe blood group A or blood group B, O, and all of that. We have product category, electronics, city, country, a lot. There are a lot of what? Categorical variable types. So many a times we use them for grouping, we use them for counting and comparing what segments. So what I'm going to say here is that if you can calculate an average from it, it's probably quantitative. And if it sounds like a label or group, it is what we call what? Categorical. I hope this has put kind of uh, to rest your bed of what type of data is. So if data is categorical, it is dealing with what? Labels and all of that. But if it is quantitative, then it's dealing with what? Numbers. Now, the question now is, how do we get data, right? Where does all this data come from? Where do they really emanate from? Okay? Because data doesn't just appear from the air when you on your journey to data analysis. It is collected from real world sources, and the quality of your source directly affects the quality of your what analysis. So you need to know where your data originates from, and it helps you judge how reliable it is. Now, some of the places where we can get data while we, as a data scientist or a data analyst, somebody who wants to get into the tech world through data analysis is that, of course, we can get data from what? Health records, okay? We can go to the hospital, collect patients' age, their diagnosis, their medication, and lab results. And then, of course, that's going to be very important for us in research. So that is where we can get data from. Now, another place we can get data from is from survey forms. Okay? We can go to we can use questionnaires, distribute them to a group of people, get their opinion on a particular information. Boom, that becomes what? Data. Okay, so we can also perform some kind of qualitative interviewing and all of that. That's also data, but probably it might go into another class of data. Now, another one is social media, okay? Like on TikTok, Facebook, Instagram, amount of data is being generated, particularly about human behavior. Okay, so that is also data that is important because while you're scrolling on TikTok, there are recommendations about some type of videos you like and trending videos and all of that. So these things are important, metrics, that transforms to become valuable if we want to make unravel insights from maybe how people behave on a particular platform or maybe towards a particular goods or whatever. Okay. Now, another thing there is from databases and systems. So business systems like CRMs, ERP software, and government databases store structured records of data, okay, that we can use for analysis. So these are what we call various sources of data. Now, the next thing we can talk about now is data cleaning. Now, as a data scientist or as a data analyst, somebody who is definitely going to go into the field, you need to actually understand that data cleaning is something that is very important. And I'm going to tell you one of the reasons why it is something that really matters on the course of your career. Now, imagine you're baking a cake, right, with spoiled flour. Even if you follow the recipe, perfectly, the result is going to be really terrible. Okay? So, dirty data is spoiled flour of data analysis. That's just a kind of an example. And then you need to understand that before you analyze anything, you must clean your data. Otherwise, your conclusion will be wrong, no matter how sophisticated your method is. So what it means is that as much as in our previous slide here, we said that data comes from some of these areas like health records, survey forms, social media, database systems, and all of that. It's important for us to understand that data cleaning is very vital, okay? And we need to actually understand that there are possibilities for us to have missing values. We can have some kind of empty fields where data should exist because people can be asked to fill a questionnaire and they wouldn't fill it, okay? And maybe the patient's records were not totally captured because some particular columns with age were not listed. And then, of course, we can find a way to fill in an estimate, like use the average age or row, maybe kind of to remove that. Now, again, it's duplicates, right? It's possible that when we get data, right, from some kind of resources and all of that, there might be duplicates. Maybe in the same record, we enter one particular patient twice, right? Maybe a customer is appearing twice in a sales database. So it's important for us to fix this and delete the duplicate entries because if we don't do that and we use that in our analysis, it's going to skew our results. Now, another one is what we call outliers. Okay, so outliers are like values that are extremely different from the rest. Example, let's say for example, you have a patient now that is aged 450 years old. Now, in that case, now you see that data cleaning plays a very massive role because it's going to help us to clip out what outliers and investigate whether it's a real value or not. So a rule of thumb here is that what data professionals spend up to 80% of their time cleaning data. And it's one of the most critical steps in the entire process. Now, guys, getting into data analysis, I'm going to be talking about descriptive statistics and how you can summarize information around it. Now, once your data is clean, the first thing you want to do is to describe it, okay? And describing statistics, which is how I used to call it, are simple mathematical tools that gives a quick snapshot of what your data set looks like. So think about it like vital signs. Now, remember what I'm talking about here is how we describe our data, right? Kind of how we summarize our data. Let's say we have a piece of a data sheet that talks about people's age or people's preferred color. How are we going to summarize those insights? That is what we call what? Describing statistics. I do call it describing statistics for more simplicity in understanding. So when to use each of them? Now, first of all, that's what the first I'm going to talk about before I talk about the trade calls. Now we need to understand that choosing the right measure matters a lot in real world analysis. So we've got mean, which is best whenever the data is evenly spread, there is no extreme value. Then we have the median, which is best when data has an outlier. So we want to use the median variable. And then we have the mode, which is best for finding the most common category. Okay. Now, the three core measures, which is just what I mentioned now, is the mean, median, and mode. Now, the mean is more like the average, right? Let's take, for example, now we have these given numbers here. We can add all of them together and divide them by the number of counts, which is going to be 30 plus 30, 20 plus 40 divided by 3. And that is going to give you 30, which is the what? Mean. So another name for the mean is the what? Is the average. Now, another thing we will talk about is the what? The median. What do we mean by the median? The median is what we call the middle value. So we usually sort our data and find the middle number. Example, maybe 20, 30, 40. The middle is 30 because it is best for skewed data. Now, whereas the mode now is the most frequent because the value that appears more often, that is what we choose. And then example is 20, 30, 30, 40. Okay, that is the mode. And it's great for categorical data. Now, the next thing I'm going to talk about is data visualization, all right? Remember here, we just talked about how you can describe statistics across, maybe it could be categorical or qualitative. And then I also did mention that in a hospital study, I was going to mention that the median age of patients is more useful than the mean if one patient is 120 years old due to a data entry error. Now, what I'm going to say here now is data visualization, okay? And apart from the fact that we are going to summarize the data, there are still opportunities for us to have a view of what the data is telling. That's what we call seeing the story, okay? Because numbers alone can be hard to interpret, especially when there is a very large data set. But data visualization transforms raw numbers into charts and graphs, and humans can now understand it at a glance. Okay, so that's like kind of a well-designed chart can communicate in seconds what a table is all about. Okay, or maybe a table that might take 9 to or how many minutes to get up. So some of the charts you will be getting accustomed with on the course of this session is what we call bar charts, because they compare quantities across categories. Okay, example could be number of patients by age group and all of that. So we use what? Bar charts for that. Now, another thing we have is what we call the line charts. Okay? In data analysis, we have what we call the line charts. And the line chart shows change over time. Okay? Example, if you want to track a patient's blood pressure reading over 12 months, you have to use the what? The line chart. Then we have what we call the pie chart, which is what? It shows the proportion of a whole. And the examples here is percentage of patients with type 1 versus type 2 diabetes. Very simple, right? But that's what we call the scatter plot, which reveals relationship between two variables. Example, you have higher age correlate and versus higher blood pressure. Okay? So the rule here is that you choose your chart based on the type of question you're answering. If it's comparison, trend, proportion, or maybe kind of relationship, then you need to find the best. Now, in data analysis, guys, patterns and insights are really very important, and finding the so what is what our responsibility is. So the ultimate goal of data analysis is not just to describe the data, is to find the patterns that leads to insights, okay? And all insight is the so what, and kind of a moment of discovery, that changes how you're thinking. So, for example, now we could talk about trend as an insight that we might unravel in a random data set. And trend here now is kind of a consistent direction of change over time. Example could be maybe a hospital admission, maybe a hospital admission increase, maybe every winter. And then this summer, we can talk about the next one, we can talk about patterns, which is kind of a recurring structure or behavior in data. Example could be maybe patients over 60 are admitted more frequently on Mondays. Okay? So pattern will help us to predict human behavior. Another thing here now could be insights, right? Which is kind of a meaningful conclusion that is drawn from the analysis. Okay? An example here is older patients in low income areas have 3 times with a higher rate and these insights could drive action and policy. Now, guys, we could actually put all of this together. Let's kind of walk through a complete realistic data analysis project from start to finish. Imagine, let's say, for example, you're a data analyst at a hospital and you've been given a data set of 100 patient records and asked which patients are at highest risk of heart disease. Now, the first thing you're going to do here now is to gather and collect your patient's record, like in form of age, blood pressure, um, of course, cholesterol, smoking status, and diagnosis history. So you first of all collect the data. And the second thing you're going to do is to clean the data, right? You fix the missing ages, you remove duplicated IDs and flag blood pressure reading as maybe maybe zero error, right? But you need to make sure you clean the data properly. And the next one is where you now perform your analysis, right? This is where you calculate the average age of risk of the risk group by finding a 78% of chance, 78, but you just find that 78% of high risk patients who are over 55 with cholesterol, high cholesterol. Now, an insight here now could be patients age 55 with cholesterol, uh, maybe over 250 milligram are the highest risk group, and they should recommend early screening. Now, I want to actually say something here that real impact, this type of analysis can help hospitals allocate resources, prioritize high-risk patients, and ultimately save lives. Okay? Yeah, so all from a spreadsheet of numbers. Now, I'm going to actually drop some kind of glossary with you to just kind of go through some terms before getting started with data analysis. Okay, so here's actually a quick, reference every important term, in the term already. Okay, now the first term here is what? Data. All right. The first term here is data. So what did we say data is? Raw, unprocessed facts and figures. So example could be age, name, Maria. Okay. Now the next one is what? Information. And what is information? Information is data that has been processed into meaning. Average age of patient is 45. What is quantitative? Numerical data that you can measure or calculate. Okay? Like blood pressure of 180 over what? 60 millimeter or mercury or whatever. 120 over 80 or whatever. Okay? Now another one is categorical or slash qualitative, which is what data that represents group or labels. Maybe blood group type A, B, O. Now another one is what we call missing values. This refers to empty fields, where data should exist. Another one is patient age, which is, of course, which is where when the patient age is left blank. And then an outlier, which is a value, that extremely is different from the rest. Okay, let's say you have age of 450. Now, for the mean, it is the arithmetic average of a data set. Okay. Now, the next one is what we call the mean, which is the arithmetic average of a data set. And we'll have the median, which is the middle value, which is when it's stored. Then we'll have the mode, which is the most frequent occurring value. And then we'll have insights, which is a meaningful conclusion drawn from it. Now, guys, that is definitely going to be that for this particular session on getting started with data analysis. I think I'm sure you really enjoyed this video. You could just go online and search your topic data sets, and then of course you can get as many data sets as possible, which you can use for data analysis. But other than that, this is just the beginning. Thank you very much for watching this video. I want you to like, subscribe, and do share. See you on the next one. Thank you.